A sample of an unknown gas was isolated in a gas containment bulb on a manifold used in this type of work. The volume of the bulb was 1.425 liters. Temperature was 25.40 degrees Celsius, and the manifold pressure was 583.0 torr. What volume in liters would this gas occupy at STP? So here we are given our final conditions of STP. So this is going to be our final state. And our standard temperature and pressure, let's assign those right now, and I'm going to put the subscripts 2 here, planning ahead for our equation that we're going to use, subscript 2 referring to the final state. Temperature 0 degrees Celsius, we always must use Kelvin, so that's going to be 273.15 kelvins, exact number. Pressure, standard pressure in torr is 760 torr. Again, an exact number, so we have as many decimal places on that as we want. The other numbers in this problem are the initial conditions for the gas. So the equation we're going to use, since we're changing both pressure and temperature, is going to be the combined gas law equation. P1 V1 over T1 is equal to P2 V2 over T2. I've already assigned the variables for T2 and P2. Now let's do the same for the other initial variables. We have P1, V1, and T1. P1 given in the problem at 583.0 torr. V1 given at 1.425 liters. T1 25.40 degrees Celsius. We need to convert that to kelvins, of course, so we're going to add 273.15, and doing the math on that, we end up with 298.55 kelvins. Our unknown, of course, is going to be V2, so let's put our question mark here. Final temperature after we change temperature and final volume after we change temperature and pressure. So let's do the algebra first, and then we'll put our variables in. We're solving for V2. So V2 is going to be equal to P1 V1 T2 over T1 P2. Now let's just put our values in upstairs for P1. We're going to slide this around a little bit. P1 upstairs is going to be 583.0 torr. V1 is 1.425 liters. And T2, let's scroll, that's standard temperature, 273.15 kelvins. 73.15 kelvins. Downstairs, T1 is 298.55 kelvins. P2 is standard pressure, which is going to be 760 torr. Exact numbers here and here, keep that in mind. So our significant figures are going to be 4 for this answer. So now we're ready to do the calculation to solve for the final volume of our gas. And when we do the calculation, we end up with 1.000 liters. For significant figures, there's our volume.